Okay, so I'm Brian Carpenter, and I'm introducing one of my colleagues, Dr. Ulrich Scheidel, who is a senior lecturer in computer science at the University of Auckland. He's been working for quite a few years now on various aspects of satellite communications across the Pacific Ocean to all the island nations. So he had a particular interest, I think, when he heard that the land connection, the earth-bound connection to Tonga, had been knocked off the map. So that's why he's going to talk to us about this event. Please go ahead.
Thank you, Brian. So, malo lele, kia ora, good afternoon. So, as Brian said, my name's Ulrich Scheidel, and I've worked in all sorts of areas that sort of impinge on data communication, satellite being sort of more recent one over the last maybe 5 to 10 years. But there's a long time ago when I did my master's in physics, where I worked in underwater acoustics as well. And so whenever I see ships going out and doing things that involve putting things into the water, especially with communications, that automatically kind of raises my interest. And of course, when you work with with places in the Pacific on connectivity matters, then the one thing that often comes up behind this is also the question, well, which technology do you use to connect? And satellite obviously is the way that you go to the smaller places that can't afford a cable. But as we shall see, Tonga is one of those places that did achieve cable connectivity in 2013. And yeah, so let me just switch over to the next slide. So you may remember that there's been a little volcanic eruption on the 15th of January in the Pacific, which really hit the international headlines. From this little island here that's called Tonga Hapai. And the island was relatively new already at that stage, and I think Shane Cronin's on here, and he may be able to later on give us a bit of an idea as to what happened there, history-wise. But it basically rose from the sea just a few years ago and has been very intensively studied. And basically on the 14th, it had a fairly significant eruption that didn't do a lot of damage. And then on the 15th, it really blew up. And this is when it hit the international media big time. And not just at the international media, it hit a lot of other things. Basically, it hits, Tonga Tapu, it hit Hapai, it hit various other smaller islands in the area. And what I'm going to talk mostly about today, it hit the two cable systems that connect Tonga. So to give you a bit of an idea of where Tonga is, in case you haven't got a world map. Now, if you go to the Pacific, you look at where New Zealand is. You'll find New Zealand sort of in the bottom left corner. Typically, Tonga is about 2.5 hours flying time north of Auckland. And it's sort of on our way to Samoa, so to speak, and then onto Hawaii. So when we fly from here to Hawaii, for example, we fly over both Tonga and Samoa, and it's about 750 kilometers east southeast of Fiji. And how big is Tonga? Tonga's got a total population of just over 100,000 people, most of whom, about 80,000 or so, live on Tonga Tapu, which is the main island, and that's also where the international fibre connection goes to. And then there's the rest of the population is sort of scattered via, across various other islands. The biggest, population sits up in Vavau, which is, another a few hundred kilometers north. A somewhat smaller population of about 5,000 people sits in the Hapai group, and then there's another 5,000 people on Ewa. But Ewa is just southeast of Tonga Tapu, and it's quite small. So there's only about 5,000 people there. So so for practical purposes, when that volcano blew, it took out two of the cables. Oops, this disappeared. Okay. So right, sorry, slide order is right. So essentially, no, let's go back. So I'll just talk about the two cable systems. So the first cable, the most important cable system in many respects, is the international connection. So it's the Tonga Tapu to Suva cables, the Suva and Fiji, Tonga Tapu over here. And as I said, that's about 750, 800 kilometers long. So 823 kilometers, if I'm not mistaken. Got that number somewhere in my head. And that was laid and went live in 2013. And I remember that very, very well, because before that, Tonga Tapu was on a 25 megabit per second satellite connection, which was painfully slow. And we were having a measurement system at the time that would measure, round trip time and arrival time, in fact, arrival times in various places in the Pacific. And when Tonga Cable turned the cable on for the first time, they didn't really make this official because they were just testing, and it immediately showed up on our measurements. And F.I. Cocker, my then PhD student, who's also helped with this work in the background a little bit, he came up to me into my office very excited and said, "Oh, the Tonga cable's gone live." I'm getting 100 millisecond round trip times from Auckland to Tonga. And so indeed it was. And, Tonga didn't look back for a long time until 2019, when they had a month's worth of outage, a month, 2 weeks or something like this, worth of outage on the cable. But that was human induced. But this time, we weren't dealing with a human, but with a very, very angry volcano. So on top of this international system, Tonga also has a domestic system, which consists of two fibre pairs, one of which runs from Tonga Tapu up to Vavau, and the other one runs from Tonga Tapu to Ha'apai. Well, I should say ran, because it's not running at the moment. So basically what happened on the 15th of January, so those of us who are in the region there, you may remember this hitting the news headlines in the late afternoon or evening here, but time-wise we're going with UTC, so that's 30 hours behind. And essentially just after 4 o'clock UTC, there was a magnitude 5.8 quake at Hunga, and a minute later observers in Tonga Tapu saw the first plume, and about 10 minutes later, the eruption plume reached the stratosphere to about 16, 18 kilometers. Sorry? Yeah, it'd be nice if you guys could mute yourself. There's a bit of noise in the background. Okay, so at about just before 4:30, there was a tsunami that was generated at the and 3 minutes later that hit the Kualofa. And I remember seeing videos of this. And when I saw those videos, my first reaction was, great, no damage to the international cable. The internet survived. We're gonna hear more about this. And there's a few videos that appeared. And then at 5:44 UTC, the international cable went dead. And then it appeared that there was no satellite backup, or no proper satellite backup. So initially, I'm just going to have a quick look to see whether I can mute the microphone is on. Oh, okay, yep, I know. Right, you're muted now. Okay, so right. So for all practical purposes, that meant Tonga was almost incommunicado. There were a few embassies that had communication systems of their own that didn't rely on the cable. So the New Zealand High Commission, for example, they had their own system there. And there were a few people in and around Tonga that had satellite phones, and that was pretty much it. So that was what we had available to talk to Tonga, so to speak. And that was enough to kind of organize an emergency response and find out that at least there hadn't been a large loss of life. But also to find out that there had been substantial damage. So New Zealand sent a plane up to have a look once the ash cloud had moved to the point where you could actually send a plane, and to do the first damage assessment exercise and everything, and then the recovery operation kind of started from there. And part of the recovery operation obviously was to get communications going again. And so what was the problem there? Well, basically, initially, there were two cable breaks that were identified. Firstly, that the domestic cable was down. There was no connectivity to either Hardpai or Vavau. And there was obviously no connectivity from Tonga to Fiji. And then that led to the activation of the cable shipment. Just to give you a bit of an idea of distances here, now the volcano is about 50, 60 kilometers away from the international cable and only about 10, 15 kilometers away from the domestic cable. So, and the domestic cable, in fact, failed much, much earlier than the international one. So, the question is, what do you do when your cables go down? Well, the first thing is you go back to what you used beforehand, satellites. Now, satellites compared to cable, I mean, cables are very, very expensive to build, but once you've got them, they're relatively cheap to operate, unless they break and they need to get fixed, in which case it is a bit expensive. But satellite capacity will typically cost you several $100 per megabit per second of capacity per month. And that's simply not competitive with a working cable that's literally going to sit there for years on end normally, and it's going to give you literally gigabits worth of capacity. And also, if you suddenly need a lot of satellite capacity, this is generally relatively difficult to organize, because in this part of the world, there's relatively few satellites compared to, say, the Americas or Africa, Europe. Which sit along longitudes where there are loads and loads and loads of customers, and also many customers that are relatively rich and can pay for this sort of thing, like oil companies and people like this. And you don't get quite that much of this kind of industry in the Pacific, and so therefore there's not a lot of satellite operators that are active with a large number of satellites over here. And usually people will not launch a satellite until they have enough customers lined up for it. And so this means that by and large, most of the capacity that you have there is already committed. If it's not committed, then at that point it's a matter of basically setting up a ground station on the island concerned. So that requires then additional things like frequency coordination. It requires a satellite dish to be set up there. It requires the dish to be aligned. There needs to be testing done and this sort of thing. And it's not something that you can do in a few hours. It's typically something that's happening in the order of days. Now, to their credit, there's a number of organizations that did actually, come to the party here. So Pacific, Intelsat, and SES are ones that I know about. I understand Eutelsat is about to come to the party as well, or it's already, has already come to the party. So, correct me on that. And various, people in the region and organizations in the regions that were working with them. Now, in total, I understand that over a gigabit per second of satellite bandwidth was deployed to Tonga. However, that's only about 15% of the normal bandwidth that Tonga has available. And since most of this, if not all of this, came from geostationary orbit, it also means you're getting longer latencies, which means that protocols like TCP, for example, that we basically use every time we send an email, every time, or most of the time when we browse, or download files of data or stuff like this, or do larger file transfers, then for all practical purposes, TCP doesn't work particularly well with those long latencies. So while that satellite capacity restored significant capability for emergency operations, it wasn't really enough to help a lot of the locals. So what happened next is that one of our local members of parliament here, Shane Retty, who's a member of the opposition party, National here, he decided he'd give Elon Musk a try. So he, basically with much public fanfare, put a tweet out to Elon Musk and saying, "Hey, can you go and help?" And so the first response was, "No, we haven't really got a lot of satellites in the area. We're not quite ready with the inter-satellite links yet." And then a little while later said, "Well, does anyone want terminals?" So they were clearly going to give it a go, and they sent an engineering team over to Fiji to establish a gateway station there. And I haven't actually heard yet as to whether that's operational yet. It was meant to, go live this week. So, maybe I'm out of date here, and if somebody knows, then, please do update me on that one. And but it was clear that it was going to be fairly challenging, because Starlink, isn't yet able to provide links between satellites. So the only way for them to currently provide service is to go from an internet-connected gateway to a satellite and then straight back down to the customer. And unfortunately, because they're low Earth orbit network, it means the satellites don't fly that high. They can't, see both a gateway and the customer unless the customer and the gateway are relatively close together. And the 750 kilometers between Suva and Tonga Tapu are really, really stretching this. So on top of this, the satellite density that Starlink has over the tropics is relatively low. That's a result of their constellation design, which is more aimed at serving the rural American and suburban American customer rather than Pacific Islanders. And there's also issues regarding how much of the sky you can point a signal at. Because when you're in the tropics, you're more likely to have a geostationary satellite lined up behind your Starlink satellite, as seen from the ground station. And so at that point, you're not really, meant to be doing this. Okay, so and also in the early days, there were concerns generally for satellite operations about an impaired signal path while the ash from Hunga was still present in the air. Now, luckily, that's largely disappeared. But obviously, there's no guarantee that that might reoccur. So there was only really sort of one sustainable answer to the whole thing for the moment, and that was you had to get the cable repaired, right? So the cable ship that was tasked with this is the Cable Ship Reliance. So it's operated by a company called Subcom, which also manufactures those submarine cables. And they were mobilized on the 21st of January, I believe, around about then. And then went first to their Apia depot. So they were in Port Moresby at the time, went first to their Apia depot to literally raid the stores, grab every spare cable that they had available, and then sailed with around about 80 kilometers worth of cable on board to fix the international cable first. Now, some of those spares that were borrowed from other cable systems in the regions, now to Subcom, for example, is responsible for the Australia to New Caledonia cable and various other cable systems in the region. And so the cable system arrived, off Tonga Tapu on January the 2nd. And in preparation for their visit, Tonga Cable had already done optical time domain reflection measurements to determine the extent of faulty cable. And they basically figured out that on the international cable, there were about 80 kilometers worth of damage, and on the domestic cable, around about 77 kilometers. So, and that photo, by the way, of the Reliance is one that I took over in Nomea, as while I was over there for the APNIC meeting a few years ago, and I was quite chuffed to see them there. So, right. So, well, just to give you a bit of an idea what one of those submarine fiber cables looks like. Now, this is from our own museum here at the at our school. And this is actually a section of the Southern Cross cable, which is not not exactly the same as the one that lies between Tonga and Fiji, but it gives you a bit of an idea of the construction of a cable like this. So essentially, in the very, very center of the cable, you have those actual fibers, and they're thinner than a human hair. And around them, you basically have a little bit of a plastic sheath to just protect them against immediate breakage, and then you have a core conduit, which is typically a sort of small plastic or metal pipe that surrounds just those fibers with a plastic sheath. And the idea there is just to basically protect them against a movement in the steel cable that surrounds it. So these bits here, they're really just steel cable, and that's needed because as you pay out cable from a cable ship to go to the seafloor, in the Pacific, you're often laying up to depths to about 5,000 meters. In the case of the area of Tonga, we're talking about 2,000 meters, and in some cases a bit more than that. And then you need to have something that holds the weight of the cable as it sinks to the seafloor, and to give it that strength. That's why you basically need that steel cable part. And then around that steel cable part, we've got a copper conductor, which is used to power the repeaters. And then around that copper conductor, you have a lot of plastic. So this is essentially insulated. It's meant to shield it from water ingression mostly. And around that, you get another bit of metal shielding and a lot of plastic and also as well, which is basically there to give it protection against the elements, against rubbing, breaking on the seafloor and that sort of thing. So that should give you a bit of an idea as to what one of those cables looks like. So to give you an idea of dimensions, they're about that thick. And depending on which cable you have, where it goes, where it's being laid, they can be a bit thicker, or in some cases a little bit thinner as well. There's different cable types that are about. So when we're basically dealing with submarine cables, so you could be laying them. So this basically means reeling them off the cable ship to the seafloor. When you're doing this, it's a specialized operation. You need to have what's called slack control. So this means that basically, you need to keep the respective amount of pull on the cable. To give you a bit of an idea, why do you need this? Well, if you're going 2,000 meters down, for argument's sake, and you're having a cable that's about an inch thick, that's about the equivalent of having a 200 meter line, roughly 200 meter long fishing line. And if any one of you's ever gone fishing with a fishing line, you just know how they love to tangle. And it's the same with submarine cables; they love to tangle. So you've got to make sure that there's always some pull on them. But at the same time, you don't want to pull them so much that they actually rip. So you need to leave a certain amount of slack in them, and getting that slack control right is one of the expertise bits that the cable ship brings along. Then once they're on the seafloor, you have to repair them. You also need to have two other skills. So you could have to cut them. So this basically means cutting off damaged pieces at the seafloor. And you can either do this by a remotely operated vehicle or by a so-called cutting drive. And with a cutting drive, what you do is you have kind of a sled arrangement or sled plow arrangement, and you run that across the seafloor, attached to a cable, sort of steel cable, from your cable ship, and you literally tow it behind your cable ship, and it's got that sled plow has a cutter at the bottom, and the idea is that basically anything that it comes through it cuts, and then it cuts the cable. And that's known as when you do this, is known as a cutting drive or cutting drag, or CD for short. And you do this literally going transversely at pretty much a right angle across the cable. The other operation that then follows is a holding drive, or HD for short. And this is to bring the cable back up to the surface. So how do you do this in the case of a sort of run-of-the-mill repair? So when does a run-of-the-mill repair become necessary? I mean, typically when somebody's put a bottom trawling device through your cable, and they've damaged your cable, then the cable ship's got to come out, and it's got to basically cut the cable at the bottom if it's not already cut completely. Needs to bring both ends up and splice them together. So there's essentially 5 steps involved. The first one is to cut the cable at the seafloor if it's not already cut. And you will typically do this with a remotely operated vehicle if the visibility allows. In the Pacific, that's, I understand, not normally a problem if you're out at pretty much open sea. It tends to be more of a problem if you're near a river mouth or something like this that's washing a lot of silt and other materials into the cable zone, in which case you might get the visibility. So if you don't have that visibility, you use a cutting drive to a CD to do this. And then what you do is you basically sail back about 2 kilometers away from the cut, and you do a holding drive on both ends. So the first end you bring up and you essentially attach it to a buoy. while you then sail to the other end, you bring that other end up. And then at the other end, what you typically do is you will then splice a piece of cable in. You will sail back, reel that replacement cable, out as you go, and we'll take it back to the other buoy that you left previously, reconnected to the cable end there, and then you let the cable, sink back to the bottom. And the way in which you do this is, again, very, very carefully. You coil it up so it doesn't tangle. So if you ever have to come back to that site and bring it back up again, you know exactly where the cable is. You don't have a tangle at the bottom that's going to get washed around and stuff like that. So the total number of drag operations that's required for this is either 2 or 3, 2 holding drives, and at most 1 cutting drive, depending on whether you're able to use the ROV on it. So now let's have a look and see what happened there. So this is the total overview of operations done today. So I should say courtesy to bigoceandata.com, who gave me a free account for a few weeks to be able to do this. So big shout out to you guys. And basically, what we see here is the cable ship arriving from up here and then going to work in the international cable area. And there's really 3 areas that they predominantly worked in: the eastern area over here, then the western area where they went to a little later, and then the repeater search area where they went to at the very end of the operation. So okay, here we go. So this is just zooming in on things a little bit. So these were the initial operations near Tongatapu in the eastern area. And what we can see here is they came in and then they essentially deployed their remotely operated vehicle to try and find the end of the cable where they thought it would be. And what they had from the Tongan end was the information that essentially the cable was terminated 37 kilometers out to sea. And so the idea was, well, it's probably got to be somewhere around there. So they tried to find it there, and they couldn't find it initially. So what they did is they backtracked a bit further until they found it somewhere around here. And then they went up here to the holding drive. So this is actually, there's a lot of back and forth involved here. So eventually when they figured out that they had something here, couldn't really trace it much further, they went back and then did a holding drive and brought it up, and then essentially pulled it back, brought it up to the seafloor, and secured it to the buoy in roundabout this position here. And then after that, they went looking for what more cable they could find, because they knew they had this about 80 kilometer stretch that wasn't reachable from either end of the cable. And so they were looking at what they could possibly recover. And they did recover a few bits and pieces. And what you can see here is they did a few more holding drives. So they went over, did a drive down, then went back and, reeled in whatever they could find. But they couldn't find anything that was really connected to anything, let alone to the Fiji end. So they did this quite a few times. So these are the bits we've seen on the previous slide over here, the 3 drives that aren't labeled. And then you can kind of see 4 more drives here. So by the way, that squiggly line here, that's the actual nominal cable route. And then over here, they basically came to a point where they were able to trace the cable, and then they kind of noticed that, hey, it's actually going off route quite substantially. And then they traced it with their ROV, and they found the cable end up here. And this is one of the most whopping and impressive numbers in this entire story. If you look at the scale, that's about 5,000 meters. It's 5 kilometers. Now, for those of you in Auckland, to give you a bit of an idea as to what would have happened here, is it's like as if you had a cable on Tamaki Drive and it got blown up all the way halfway onto Rangitoto Island. So this is really a whopping cable displacement that you're talking about here. Now, interestingly enough, and the sort of initial media statements all said, it's the explosion from Hanga that did it, or it's tsunami and everything. But what you're noticing is, Hunga is actually up here, another sort of 40 kilometers off the top of the screen. And what we're really looking at here is a displacement in the direction of the volcano, not away from the volcano. And now, you know, if you've ever done chemistry as an undergraduate student or a secondary student and you've caused an explosion there, as you know, most of chemistry students would have done at some point, you know that if something goes boom, things fly away from it, they don't fly towards it. So this was the first, the first thing where I thought, hey, you know, this is probably a typo in Matangi Tonga. And then, you know, I asked him, no, it's not a typo, it was indeed. And this was the only time that the Reliance actually had to go that far away from the cable route as part of its operations. So that's an interesting bit. And again, that sort of together with the timing was a little bit of a heads up for me, because I looked at all of this and said, okay, so we have an outage on a cable that's not associated either with the initial blast of the volcano, it's not associated with the tsunami that hit afterwards, because, you know, there were still videos of that tsunami being recorded and being uploaded to social media before the international cable went down. So my initial question was, you know, has there been a secondary event? And so this is what I went to Shane with, Shane Cronin, who's a local volcanologist here, and he got, you know, a bunch of other people involved, you know, James White at Otago and Colin Whittaker at Auckland, and then, you know, also people at the Crown Research and NEVA community here, who are involved in oceanography, various aspects thereof, and they've all been, you know, giving really great input into, you know, into all of this, and the debates between us are actually, you know, still ongoing in many ways. So, you know, I'm hoping to learn today a little bit, especially when after the comments and the questions coming. So, and then basically after locating this piece of cable that had been blown sideways by 5 kilometers, the Reliance went over to the Western Cable Ground. And so, you know, first answer as to what secondary event or what would blow a cable away for that distance, basically turbidity currents do this sort of thing. Now, turbidity currents aren't, you know, the geologists, please here, you know, do correct me if you get this wrong. They're basically water currents that do carry a lot of sediment, and in this case, probably volcanic ash and other debris that, you know, has come off wherever that turbidity current starts. They're known to start on slopes in the ocean, very often as a result of earthquakes, but, you know, also things like volcanic eruptions and so on. And they can travel literally for over 1,000 kilometers. But in this case, because of the direction of the displacement, it's likely that the turbidity current that blew the cable off course here did not actually come from Hunga, but from somewhere else that would have been south of the cable route. And that's kind of got us to prick up our ears a little bit. So typically it'd be something like submarine landslides. There's actually been a 1929 earthquake banks in, you know, off Newfoundland. And that at the time cut about 5 or 6 different cable systems, you know, over there. Even in 1929, they had telegraphic and telephone systems there. And they were also cut by, you know, by what seems to be a single turbidity, you know, current, and they were cut on a single downhill, more or less downhill slope, and they were cut over a period of about 12 hours as that flow progressively made its way down that slope. So a question is, you know, did we, possibly have a submarine landslide here? And also, what would have caused the landslide? I mean, you know, were there just slopes that were waiting to go? So the question is, you know, why haven't they gone with previous earthquakes? You know, were they possibly charged by, you know, heavy ashfall from Hunga? We certainly know that there were significant amounts of seismicity, you know, around Hunga, but mostly to the north of the cable, with very little to the south. And the question is, you know, if it wasn't Hunga and there was a turbidity current, was it just one event, or were there possibly several events that caused trouble? And the thing is, basically that theory fits with the relatively late failure of the international cable. So for us, you know, that's certainly a theory that we're, you know, currently looking at, but we can pretty much exclude the initial explosion of Tonga doing the damage, and we can also pretty much exclude the tsunami having done the damage, although we're still waiting for some, tsunami modeling to be done to see whether there are possibly any sort of nasty surprises coming out of this. So going out west now with the cable ship, what what happened out there is they apparently had trouble with their remotely operated vehicle. When they put it down, they noticed that there wasn't much visibility, so they basically proceeded with a cutting drive and two holding drives, so very, very classic repair option. They also found some fiber damage a little bit further along the cable, and while they were at it, went out and repaired that as well. And that's just what you do, as a cable ship. So, so the question for us also was a little bit, why would there have been low visibility? I mean, if it was just an aftermath of Tonga's eruption, as such, then obviously the depth near the Tonga Tapu was similar, but they seem to have enough visibility down there in order to use the ROV quite extensively. You can tell this because, from the trace, because they're proceeding very, very, very slowly and they're going along the cable route. Here in this case, they didn't go along the cable route and they just basically, went and did their drags. So question is, what would have caused the visibility problems out there? Was there another turbidity flow still going on at the time? And and then also, when would that have potentially started? And, also, did the damage to the international cable maybe start with a cut close to Tonga Tapu and then further damage, further towards Fiji later on? So this is a possibility. There's also, of course, the possibility that there was damage done on the Fiji side, further towards Fiji first, and then, Tonga Tapu was taken out a little later. We don't know that. Could have been in either sequence, right? So then looking at what they basically did till earlier this week for the last week. So essentially what they did is they were looking for a missing repeater. Now repeaters are things that you need to put into fiber optic submarine cables, depending on cable type, on the type of fiber used, and also on the type of use you want to put it to. And you typically, on the type of cable used, for Tonga Tapu, the specifications kind of say 1 every 70 kilometers. I understand that there's one about every 130 kilometers on that cable, which probably more or less indicates to me that this is a cable that was never, intended to be used to full design capacity. And then you can get away with slightly, weaker light levels further down the, further down the line. But they did a few holding drags in that area here in order to bring hopefully a piece of cable with a repeater up. I understand they weren't successful in doing that, which is a bit of a pity because those repeaters, they're quite expensive. So the chief executive of Tonga Cable, James Panuga, he was quoted in Matangi Tonga saying it was a $230,000 US for the repeater. And if you're having an expensive repeater like this on the seafloor and you can bring it up, it brings your repair bill down quite substantially, obviously. But there's also a limited amount of effort you want to put into this because ship time is also quite expensive. So they weren't successful with this. Then went over to the eastern end briefly, basically just to check whether their buoy was still there, which you want to do if it's been out in the weather for a week or two. And then they went back to the western side and basically commenced repairs there. And so those were completed on Sunday or Monday, Monday I think, with the final splice near Tonga Tapu, and then it took another, a good part of the day to do all the testing, switch the ISPs over, put the cable back onto the seafloor, do the testing, and switch all the ISPs over to the cable again. And so as of Tuesday afternoon, Tonga Tapu's been reconnected to the internet, again via fiber. So the outcome so far is that basically, of course, Tonga Tapu is reconnected, and in the process of the repair work, the cable ship brought up about 40 kilometers of the cable, some of which went, straight back into the repair. Because in order to cover those 80 roughly 80 kilometers that were zapped. They had to lay about 90 kilometers of cable. Now you ask me, why do I need 10 kilometers of extra cable? The simple answer is, if you're laying cable that was previously on the seafloor, you got to bring both ends up, and by the time those both ends are at the surface, there's a gap between them, and you have to bridge that gap, and that's the extra cable that goes in. And obviously, if you're having your cables 2,000 meters down and you're bringing them up, the gap's quite substantial. And then it's basically sort of simple mathematics. If you've arrived with 80 kilometers, you've acquired another 40 kilometers while you were working, and you laid 90 kilometers, you're left with about 30 kilometers on your ship. Now, but the domestic cable system will probably need about 80 kilometers ballpark, in terms of a cable to be laid for repairs. So it's fairly clear that we don't have nowhere near enough cable on that cable ship at the moment to repair that, unless there's enough serviceable cable on the seafloor, from the domestic system, that if it's being brought up and spliced to the 30 kilometers or so on the cable ship, that'll be enough to bridge the gap. And the current assumption is that probably won't be the case. And then at that point, it'll be a matter of getting cable in, and this sort of cable, especially in larger quantities of kilometers, is fairly heavy. So it's not the sort of thing that you can go and order from Amazon and have air freighted in. There's just nobody who can air freight that sort of stuff in any quantity. So you have to bring it in by ship. And I understand it's got to come from Europe. So you're basically looking at, even if it's already been manufactured and everything, and again, that sort of stuff typically gets manufactured on demand, not in advance. Then what basically happens is the mere shipping time would probably be in the order of about a month, or just over a month, just to get from Europe through the Panama Canal into the region. Okay, we're going for time. Not too bad. Okay, so meanwhile, Starlink sent a large number of terminals to Tonga. So and the Tongan government's kind of taking control of those, and I understand has sent them to various islands that don't really have connectivity at this point. I'm quietly hoping that they've retained a couple of terminals for use on Tonga Tapu in case we've got further outages on the cable, because one of the big questions that we have from the geological side of things is, if we possibly had multiple landslide events along the cable route, are there possibly other slopes that are primed and ready to go, especially with a fresh layer of ash on them now? And could they possibly be triggered in the next few weeks or months, and cause another international cable outage, which of course then again probably couldn't be repaired due to problems with the with the cable capacity that's currently available. So I haven't really had any feedback yet on how well Starlink is working in Tonga. I understand people who have it working here in Auckland do with a much closer gateway do get outages typically on a roughly hourly basis, but they also get very nice high download rates at times. And obviously my hope would be that whatever they've done on the Fijian side, that it would provide at least some reasonable service to Tonga, although as my Tongan friend told me this morning, we'll take anything at the moment, even if it's got several outages an hour. And I guess good on Starlink for for doing that. So basically, what Starlink do? So they established a new gateway in Suvan. They were supposed to go live this week. So my question is, will they be able to provide continuous service to the 50 terminals? And if so, at which data rate? And my other question will also be, now that we do actually have a cable that's running over to Tonga Tapu, wouldn't it be maybe a good idea to put a ground station gateway there as well? Because that would certainly solve some of the problems of the long distance and the lack of satellite density in the right sort of locations. And, also the other place that, one could think about potentially putting a gateway would be in Newell, which is cable connected, and, which is, almost within earshot of Tonga's northern islands. And so that might be a, good place to go as well. So if Elon Musk or one of his, people, is listening, then, I'd really like you to go away and think hard about that. But, while everybody's in the public's been talking about Starlink, a lot of the loads for the bulk of the time has actually been shouldered by other satellite providers. Now, I know that SES was involved, Pacific, was involved or is involved big time. Intelsat, and I understand Eutelsat's been involved as well. And a lot of that capacity, I understand, is now being redirected to Harpai and Vavau, who haven't really got connectivity, in spades at this point, and who are still mourning the absence of their cable. And hopefully something will be able to work out there. So anyway, coming to my conclusion, and so we'll have plenty of time for questions and comments afterwards. So essentially, the one really surprising thing was the very, very massive cable damage that we've had here. And the location of that cable damage basically, points at turbidity currents that weren't coming from Hunga. And so again, this, puts up the big question as to whether there could be more unstable slopes that are lurking in the vicinity of the cable, or, maybe for that matter, along other cables elsewhere in the region that could be presenting a threat to the cable and or cables, and that might be triggered in time to come. So also the timing of everything and the timing of the visibility, and I should put this under the caveat, some of the data that we have there at the moment is quite preliminary and pretty much secondhand, but it suggests that there may have been multiple turbidity currents that we were dealing with that might have gotten triggered at different times. So then, of course, the loss of that link also underlines the need for redundancy. To places as big as Tonga in particular. So I understand that there's a second cable in the planning as an offshoot of the Hawaii cable, but it's some time off apparently, because there's no money for it yet, and donors are currently being consulted. Again, if donors are listening to this, I would very, very much hope that a solution there could be found. I think also Starlink could have really made a difference here. In about a year or so, once they've got their satellite links, going, because I mean, even 50 terminals, while it's better than nothing, it's not a replacement, for a for a full cable running, into a place like Tonga Tapu. In this case, you'd probably be more looking at, between 5,000 and 50,000 terminals, right? But I think if one thing's really, come off this that's really, really good, is that the Pacific is now on a lot more people's radar. I think previously it wasn't really on Starlink's radar. There was very little in terms of gateway stations for the tropical Pacific. The only one that was on the tropical Pacific thus far was a gateway station in Hawaii. But now, of course, there's been one in Fiji. There's a good question as to whether there couldn't be a few more on the place, right? And I hope we're going to see a few more. And once intersatellite linking is going to be working, we should also be able to get to slightly more remote islands that currently have, very, very restricted connectivity, with it. And so I'm holding, great hopes for Starlink. But I'd like to see all of this accelerated a little bit, right? And it's good to know that at least Starlink got engaged here, and good on them, and I hope very much it will stay on their radar, in months and years to come. Okay, so I'd also like to say thank you to a few people. So first of all, again, to Big Ocean Data for making the ship traces available. It's amazing how much you can read into the ship traces if you know what a cable ship does. Then there was an engineer at Tonga Cable who's preferred to remain anonymous, and he's answered a lot of questions that I had, and he's confirmed a lot of my theories, or debunked a lot of them. Then my former student, Edward Cocker, for letting me use, his network has put me in touch with a number of people. And then, of course, to all the volcanology, geology, sedimentology, hydrology crew, Shane Cronin, James White, Colin Whittaker, Paul Jarvis, and their respective teams. And I think one of you are, one or two or three or five of you are actually, here now as well. And so thanks a lot for, taking my concerns seriously early on, and for willing to engage with me on things. And then also big shout out to Shane for putting Elon Musk on the spot. Normally, Elon doesn't really talk to anyone else but Twitter, at least not in the research community. So it's very, very little that we know about Starlink, except from the FCC filings that they do, and other intelligence that sort of comes in from various sources. But they don't publish what we publish, and they don't, go to the conference that we don't tend to go to. And so it's sometimes a little bit difficult to find out what they're up to, and how they're attacking particular problems. And I would quite hope that maybe there'll be a change in that in years to come as well, because I think the research community has a bit of input to give as well. And there were many others involved on the sidelines with input, questions, and opportunities. And and with that, I am ready to take questions. Now, I'm just going to have a quick look at the chat to see what's come through. Right. So Michael Richardson's asking, let me ask a stupid question. Do undersea cables have unique L1, L2 layers? Is it Sonnet OC 192 plus with Ethernet adaptation, or has the world moved on from what I knew in the late 1990s? Well, my understanding is that they're still using fairly unique physical and data link layers, and that the things have certainly moved on. So on the physical layer side of things, for example, in the 1990s, you would maybe use one or maybe two wavelengths, in other words, colors of light, and now the number of colors of light that you would use to communicate would have gone up quite substantially, which is why when you have one of those submarine cables, they're really like a resource that's going to last you for 10 or 20 years. And when you buy a computer, it's basically rubbish after 4 or 5 years, because technology's moved on. With undersea cables, that's a bit difficult. What you change with undersea cables isn't the cable itself, you change the equipment at the far end of the cables. And so that then allows cables to be upgraded to higher capacities over time. And so that's obviously something that I would also like to see with some of the other cable systems that have been deployed around the region to basically see them grow with the technology over time. But that's basically because the expensive part of a cable is the laying of the cable. It's not the actual terminal equipment at either end. So Daniel Sokolov is asking, is anyone from Tonga here? Well, I can certainly spot a few Tongans on the list, but I can't see anyone who's actually sitting in Tonga at the moment. But I can see somebody from Fiji, but I may be wrong. So if anyone's from Tonga, then feel free to put your hand up and say, great.
Yeah, I put my hand up.
Edwin. Right, cool. Okay, great. Super, welcome. So Edwin's okay if you tell people who you are?
Yeah, like I used to be.
Yeah, Edwin used to be the CEO of Tonga Cable, but he's no longer working for them.
Yeah, but Ulrich, can I ask you something?
Sure, go for it.
I'm a bit shocked that Pacific is not mentioned with all the redundancy packages for Tonga, because like Pacific was discussed way back 2019, even before the first cable break.
I thought I mentioned them as the ones who provided the 1 gig link for the backup.
Oh, maybe I joined late.
It may have been part of the sentence, but I think I did mention them.
All right.
Yeah. They definitely jumped in, and I should also say this was against the background of them having a fairly serious legal argument with the Tongan government at the time of the volcanic eruption, and they decided, to put that aside and basically say, okay, this is what's needed now, and they jumped in.
And there was already 50 terminals, Pacific terminals, on the ground in Tonga.
Yeah.
Way before the cable break.
Yeah. Well, I realized you even had ISPs at the time who were using
yes.
you know, who were essentially using Pacific, and all of that kind of fell by the wayside of it. Okay, so then
And TCC is still using Pacific, and they have asked to move all the capacity to the outer island since Starlink is not working properly.
Yeah. That's what I heard from Tonga as well. That basically a lot of the existing satellite links into Tonga Tapu are now being shifted over to Davao and to Hapai. And yeah, having been both to Hapai and Davao a long time ago, I know that there are, you know, fairly small pieces of land with, you know, people on them that, you know, desperately need that sort of thing. So it's good to see that happening, really. Right. So the comment from Fintel that as a direct message to me saying SpaceX is operational from 16th of February, formally launched in Tonga yesterday. Okay, so hopefully that's all working now. It'll be interesting to hear how well it's working. Right. So Nathan's put something in. There's cool special software that controls payouts and the boat's speed direction combined with the topography and currents. Indeed. But that's what you pay a cable ship for having that sort of stuff. And that's a real skill. Yeah, and then there's a question from Daniel to Edwin. How were the past weeks for Tongans on the ground, and who had access to the internet service over satellite? Can you answer that, Edwin?
Yes, TCC is on Pacific.
Yeah, so basically only TCC had access to satellites.
Digicel has access to satellites, but on another service provider.
Yeah.
But Tonga Communication Corporation was on Pacific.
Yeah. I understand Digicel were working with Intelsat.
Yeah.
Not sure who was working with SES, but maybe if there's somebody from SES here, they might be able to enlighten us. Right. Okay, so that's the end of the questions. See, anyone else got any questions?
Just a comment, Ulrich.
Yeah.
A lot of interest in Tonga these days, so it's good to see a lot of competitors, which is good for the region.
Yeah.
But not too sure how much of advantage it will bring to the island. Pacific is there, which is good. Elon Musk is there, but then the new fibre is just recently been repaired, so it will be interesting to see over time how much of the bandwidth have changed in Tonga.
Yeah. It'll also be interesting to see quite how much how much service quality our Starlink users in Tonga will get, because the distance between the ground station in Fiji and Tonga is actually quite substantial, and so I would presume, especially also from what we're still seeing here in New Zealand, is that there would be relatively frequent service disruptions and outages. But I mean, then again, I'm pretty sure that playing Fortnite is probably not at the top of the needs list in Tonga at the moment. And for stuff like, even if it's just simple stuff like email in order to get out things like orders, or very, very important, I know, for a lot of Tongans, to have things like MoneyGram and Western Union working. That's the sort of stuff that really makes a difference on the ground. And especially also going out to smaller islands. And this is where I really also see the Starlink potential in future times, because they're a relatively inexpensive and very, very transportable service. And so if you have islands, and I know you have a lot of them in Tonga with 20, 30 people on them, there's just no way that you ever want to put a cable over there, because it's just there's just no business case for that ever. But a Starlink terminal, on a place like that, especially if people can share it, that's the sort of thing that's going to make a big, big difference on the ground. And again, also my concern, and this goes to anyone who's basically working in the cable infrastructure, business there. I think there may be a few knock-on effects from this. About the amount of spares, for example, that you should be, keeping in store, in the case of a major disaster event like this. So maybe not just 10 or 20 kilometers of spares, but maybe keep 100 or 150 or something like this, depending on how long your cable are, how exposed it is to recognized hazards. And Hunga Tonga was certainly a recognized hazard. And also, maybe look at, what you can do with, in terms of having, maybe a sort of satellite solutions ready to drop, type network around the, around the Pacific, basically saying, okay, there's going to be a few channels that we're going to keep reserved for any country that's, struck with a cable failure, and this is what we're going to use, right? So there's people on the ground in those countries who know this is the satellite we'll be using, this is where it is, this is how we're going to dish it, this is the receiver that we'll be using, and so that literally they can go and reestablish communication within hours. But also there'll be consequences probably around, cable routing and stuff like that. You probably want to avoid places that have slopes next to them, right? But then again, this is really, really difficult because there's lots of slopes in the Pacific, and a lot of them are quite steep, and with turbidity currents being able to, travel for 1,000 kilometers, there's virtually no place that's entirely safe of them, right? But yep. And yeah, so there's a few more comments here that have come in. Yeah, so basically from Imani, who of course is well known as being an old hand at the internet in Niue, and good to see you here, Imani. Basically saying Niue has undersea fiber with a tiny economy, not cost effective with a few hundred paying customers. Now, the thing, of course, is that, whether you're able to get fiber or not depends on who pays for it. And it also depends on how far you are away from a place where you can tap into fiber or fiber connected internet. And over summer, I've actually worked with the research students over, trying to get a catalog of, every small island in the Pacific to see how they're connected. And who the local telcos are to talk to, and internet service providers, and how one might get there for deployment. And it sort of there seems to be a sort of rubbery rule that says the moment you've got a population of about 5,000 people, and you're not too far away from a place that's, that already has fiber internet, you have a fairly good chance of being connected. If you're further away, then maybe 1,000 kilometers or something like this, and for fewer people, then it's a bit of an issue. But that's not a hard and fast rule. But, we're seeing places like Tonga with about 11,000, 12,000 people, getting connected these days. We're seeing, places like Niue with just over 2,000 people getting connected. But, very often what they are able to offer us that they happen to be, in a location where it's worthwhile putting a cable in that connects to other points that would like to connect to each other, for something like redundancy. And my comment to Imani would also be is if, for example, Starlink would be able to, put in a, a ground station, in Niue to help pay for the cable there, and then, have, have that used in order to provide, service to northern parts of Tonga, for example. That would be a thing. Similarly, if Starlink could go to places like the Cook Islands and then provide service to other places in the Cook Islands. I know they're getting pretty good service already with O3B there, but obviously competition is always good. All right. Carrying on. Brian Carpenter had a comment to Michael Richardson. Ethernet over SDM is probably the usual answer. I don't know if Ethernet over SDM is 16 is a thing. Consider it to be Sonnet OC 192 on steroids. And Emmanuel said fiber is a couple of $100 US per megabits per second, similar to satellite. I guess if you're paying for connectivity as a service, then that's probably what it works out to be, because in that case they're competing with a satellite, and then they have to be a lot cheaper, right? Shane Cronin, so again, reminder, Shane is the volcanologist I've been working with over the last few weeks. There's a long-term issue for monitoring the isolated and commonly submarine volcanoes in Tonga. Could cables be used more effectively for this than currently? I've seen some news that this is planned, but there are many point source volcanoes and not many cables. Yeah, good comment, and I think definitely it's a comment that actually David Lesnar at the University of Hawaii made a little while ago. Now David is the president of the University of Hawaii, so he's an old Datacom's hand. So Brian knows him quite well, I think. And he gave a very, very impassioned speech at the IEEE GlobeCom conference in 2019, which was the last one that we could all attend in person. And he basically said to us assembled European and North American and then Asian colleagues, and basically said, look, folks, the Pacific is actually a really important place for telecommunication. There's an enormous amount of research going on here, astronomy, climate research, geosciences, and in all their forms. And he's been a big advocate for this sort of thing. So definitely very good point, Shane. So from Nathan to everyone, is SDH still in use on modern cables, Brian? Okay, I'll leave it to you to answer that, Brian, if you like.
I'm not sure I can actually without doing quite a bit more Googling than I have time for right now.
Yeah, my understanding is also it's mostly wavelength division multiplexing that's going on these days.
Oh yeah, sure, but that doesn't mean you can't layer an SDH interface over it.
Yeah. I mean, it's one particular part of the stack that I must admit I haven't really paid a great deal of attention to. Nathan, the reason, so this is from Michael Richardson. Nathan, the reason I assume all this stuff is because the amplifiers in the cable aren't easily replaceable like there are on land. Typically, the amplifiers are physical amplifiers, analog amplifiers, and they're optical amplifiers. So they tend to work with whatever terminal equipment you place at the end. And they're designed literally to work for 10, 20 years without requiring repair. So it's a comment from Brian there, and from Nathan Gotcha. Right. So any further questions, comments?
Just a big thank you, Ulrich. That was very, very interesting.
Well, thank you to the audience. I hope I've learned a few things today. Obviously, if only about when Starlink took off, and also about the number of Pacific terminals in Tonga. It's good to see that there's so much out there at the moment, and I hope that something good will come off this. I mean, as people say, never let a good crisis go to waste, and I think in many ways that's been a good crisis, and I hope it's going to work out really, really well for Tonga, but also for a lot of other places in the region, which I think having similar challenges and having those on a day-to-day basis, not just when a volcano pops up in their neighborhood. Righto, and if that's it, then I will probably now have to have a drink of water and a bit of lunch. And I'll be putting the recording, I'll see how I go. I'll either put it on YouTube or on our local WordPress site here. But depending on how that goes, we'll be pushing the links and to the video and to the slides, probably tomorrow sometime, into the channels through which I advertised it. If you would like the links and you haven't received them by tomorrow night, then please do let me know and I'll send them to you then. All right, thank you. Bye bye everyone.
Thank you.
Thank you.